form. It's not factored form. It's called vertex form. Okay? Okay, today we're going to learn how to convert from standard to vertex. Vertex form is the third and final form of quadratic expression. So we've learned standard. That's when it's all multiplied out. My highest exponent, x squared, is on the left, right? And we've learned factored. That's when it has two parentheses. So now we're going to learn our third and final form. It's called vertex form. First, let's look at the following standard quadratic equation that is turned into factored form using the box method. So notice how on this one, I needed two numbers that added to 6. Right? I needed two numbers that added to 6, but multiplied to 9 and ended up being 3 and 3, right? Now if I were pulling out the GCFs, that's how I came up with the factored form here. Now this type of quadratic trinomial is special because both sides of the box are the same, okay? Notice how both factors are the same. So this type of quadratic trinomial is called a perfect square because literally the box is a square, right? Same on both sides. Oh, Brooke, I let people pick their own seats today, so you can sit in either 17 or in 20. Those are the open ones, okay? Because both of the factors end up being equal. They're the same. Okay? Instead of writing x plus 3 times x plus 3, we can write it like this. X plus 3 squared. Right? Okay. So it's called a perfect square because literally it's a square, right? Same thing on both sides. So far, so good? Okay? Now, what vertex form is we are going to force things that are not perfect squares to actually look kind of like perfect squares. Okay? What we are going to do in class today is force quadratic expression functions that are not perfect square trinomials to look like perfect squares. This process is called completing the square, and will be how we convert from standard to vertex. We will not learn why this is called vertex form until next unit. What is the defining characteristic of a square? What makes a square a square? Yeah, same side lengths on all sides. Okay. Okay, what we're going to use on this one, it's called the extra box method, okay? So this box has a garage, all right? Now, one thing I know is that this box here is always going to be my x squared. I already know that. Now, in factoring, excuse me, the other box that I know is the bottom right box, right? But that's not true in this case because we're not factoring. Okay? Here's what I know. I know that if this is going to be a square, then these have to be the same thing. Good? Does that make sense? These have to be the same thing, right? And what are these going to add to? Anybody remember? Yeah, Gavin, 6. Good. These are the boxes that always add to the middle number, right? So there's only one possibility. Well, because they have to be the same. 3 and 3. Okay? So first step for completing the square is take your B. When I say B, what am I talking about? The middle one. And divide it by 2. So B divided by 2 is 3. So that's what I know goes here and here. Okay? So if I know this has to be a square and it has to be the same thing, then I know that this is going to have to be 3 and this is going to have to be 3. Everybody good? So what does that make my bottom right box?
8.
Nope. Nice guess though.
6.
Nope. 9. Because what? How do we find this box? 3 times 3, right?
But what happens to the 8?
But what happens to the 8?
It goes in the garage.
No, the garage. That's a good guess though. The garage is what we need to do to make the 9 8.
Why is it 9 again?
Because 3 times 3. Here's what I want you to notice. Guys, hold on. Here's what I want you to notice. For me to get my standard form, guys, listen. For me to get my standard form, I add up all my boxes, right? So x squared plus 6x plus 8, right? That's how I would get that, okay? But that's not what I want to get again. I'm turning into vertex form. So to do that, what I'm going to do is I'm going to take my x plus 3. How many of those x plus 3s do I have? 2 of them. And then minus 1. That's vertex form. How do I make the 9 become 8? Huh? Yeah, because the minus 1 isn't times by any of those. It's just being added on the end. So after I FOILed out the x plus 3 squared, I could minus 1 to make the 9 8. Okay, we're going to try another one. Okay, step 1. I put in my x squared. Okay, then take my b. What's my b? 6, and I cut it in half. Now, I cut it in half, remember, because I need this to be a square, right? I need it to be a square, so I'm always going to cut it in half. Okay, so what's 6 over 2? 3. So what's my bottom right box? And how do I make 9 become 10? You got it. So my vertex form is x plus 3 squared plus 1. Okay? Sure. Yep. Okay, let's try another one. Okay? X squared plus 4x plus 8. Put my x squared in. What's my b in this one? 4. So 4 over 2. What's 4 divided by 2? 2. So then I know that these are my 2's. So that gives me this. Okay. What's here? 4. And how do I make 4 become 8? Plus 4. So my vertex form is x plus 2 squared. That's where these are. Plus my extra box. Do you guys think you could try 4 and 5? Yeah, try 4 and 5.